Here we have a triangle, and we're told that JK equals KL. And we're told that X is equal to 60. What does JK equal? Well, remember, equal sides are generated by equal angles. So if JK equals KL, those are two equal angles. And if we subtract 60 from the 180 degrees in that triangle, we get 120 degrees left over. So J plus L have to equal 120. If J plus L equal 120, J equals L. Each of those is a 60-degree angle, so we have an equilateral triangle. All the sides are equal. So JK will be the same as JL, and as KL, each of the sides will be 6. In this figure, we're told that the sides R and S and T are 13, and that height is 12. That perpendicular line is 12. Well, we want to find the length of RT. Since the only right triangles we've got are the two smaller triangles, what we'll do is we'll solve for one of those sides. We'll label it X, and then double it to get the length of RT. We know that those two lengths will be equal because we've got congruent triangles since we have the equal sides and angles. We can solve this two different ways. We can solve it using the Pythagorean theorem, which we'll show you in a second, or we can realize this is a special triplet. This is a 5, 12, 13 right triangle. Remember, there's the 3, 4, 5. So if we remember that it's a 5, 12, 13 triangle, we know that X is equal to 5. If we choose to use the Pythagorean theorem, we remember that a squared plus b squared equals c squared. So that tells us that 12 squared plus x squared equals 13 squared, which tells us that 144 plus x squared equals 169. So x squared would equal 169 minus 144, or 25. Taking the square root of 25, we see that x is equal to 5. We've got two x's, so the length of RT is 10. This question asks us to determine the perimeter of triangle POR. Well, this is going to be really easy if we remember one thing, and that is the 3, 4, 5 right triangle. Because if we look carefully, we can see that in the triangle on the left, you got 3, 4, PO would be 5. And the triangle on the right, you've got 4 and 5. That shorter distance there would be 3m. You could also solve this using the Pythagorean theorem, a squared plus b squared equals c squared, and get the same results, but the 3, 4, 5 is not only quicker, it's more efficient. You don't have any room for computational error. So remember, 3, 4, 5 right triangles show up all the time on the SAT. So if we add our sides together, we get 5m plus 3m plus 3m plus 5m, 16m.